Hello, hello, hello. So today, I'm going to talk to you about something which is called application of coordinate geometry. Usually, when you look at the geometry question, you find it really hard to actually identify, well, the so-called similar triangles, or you can say the congruent triangles. It's very hard, right? So why not we use a very special alternative to this question, which is the use of a coordinate geometry. So, in order to really use them properly, we have to know some basics like the section formula, the first and foremost, the section formula because this question involves the ratio. They want you to find the ratio of the red line to the green to the purple line. So we have to find the ratio. So we have to know the coordinates of this point, this point, this point, and this point. And hence, we are able to get the coordinates. Once we are able to get the coordinates, then we can find the ratio and combine the two ratios into three. Okay. Now, the section formula, well, which is something like this. When you have a line, for example, like this, and you have the line consists of 3 points A, B. Well, initially the line connects between A and B. Then there is a point called the section divisor. Well, we divide. Well, the point we call it as a O. It divides between A and B. So we have a ratio of M and N here. And given that the coordinates of A and B are x1, y1, and then B is x2, y2, and we can actually use these coordinates and these two ratios to get the coordinate of O by using the formula of, well, the coordinate of O, we name it as AB, okay? And then it equals to x1 n plus x2 m over m plus n, and then we copy down for y1 and y2 at the same time with n and then m and then over m plus n, and that's all. And then we can get the coordinate of A and B. But the main criteria, one of the criteria of using this formula is that we need to have at least 2 points, okay, identified, like A and O, or O and B, or A and B, okay, one of the pairs, you must get it. And the second thing you have to know is how to derive the locus. So in SPM, we know how to derive the equation of circle, okay, which we're gonna use it right now. And then the second one is the equidistant thingy. Well, or you have a specific, well, the distance ratio, and you try to derive them using the distance formula, and you will get the locus equation. But in this case, we're gonna use the circle equation. Well, so obviously we need to denote some points. We assume that, well, in this case, we have two similar circles, okay, very importantly. So they have a radius of r, this is center, then we have a radius of r here, and hence we can denote some points, like we can start from here, the origin, like this. We have the origin, which is here, A, and then we start off with the second one, which is the P. You will get r comma r, and then the M will be 3r comma r, and then the r, which is on the top here, you will have a 3r comma 2r, okay? Well, r is just this distance actually, or this vertical distance, because in this case the circle touches the horizontal and the vertical. and the horizontal and vertical are actually tangential to that circle. I mean, each of, well, depending on which side you want to refer to. So after you have denoted these points, okay, you must, well, you should be able to get the P and the M first. Is very important, well, especially the M, because I'm gonna denote the locus of equation at M using of the circle using the point M. So well, the first important step is to derive the equation of straight line which connects the point of this to this, which is actually, this is O and then this is R. Okay, we know that we have 2 points which are the P, this point, and then R. So if we have 2 points, then we are able to get a gradient. So the gradient I denote it as a small m of the straight line O. From the beginning, this is O, and then to R, this is the n, and then we will be able to get the gradient of the straight line, which is 1/2, because we cancel out the R at the same time. Okay, so not to mention, we have also the y-intercept of OR because of the origin, this here. So on the top of the A, which is the origin, you have a point of O. This is obviously the y-intercept. So that's why I name O as the y-intercept of OR, okay, which is C. And then you can use the equation of straight line, which is y equals to mx plus c. As usual, we have a gradient of 1/2 x plus c. You can use any point of any coordinate, which is r comma r, or maybe you use 3r comma 2r, and then you will get the same thing, which is r/2, the final answer. Okay, the c equals to r/2, and hence the coordinate of O is 0 comma r/2, and hence this is the equation of the straight line OR. And we're gonna derive the equation of the circle B, which is this circle. So the circle has a center of 3r comma r, and we know that any point on the circumference of B, like for example this one, we always have a constant distance to M. So the constant distance, which is the radius in this case, we have denoted the radius as r for each circle. Circle A has r, circle B has also r, and so we can derive the equation of locus, okay, by arbitrarily denote any point on circle B. Like this case, we use x, y again, and then we try to connect between the x comma y, 3r comma r, this one, and also r. So how to get the locus of equation? I mean the equation of circle. We can just use the Pythagoras formula, okay, like this is x, y, and then this is 3r comma r, okay, correct. And then we have a distance here to here is r, and r is always constant because xy is moving on the circumference. So we have always the radius, and hence we can get this equation, this Pythagorean form, and then we are able to get 5y squared minus 18ry plus 16r equals to 0, I mean r squared. And then so actually we do have x here. So notice that I have substituted the x in terms of y from the equation of straight line OR, which is this one. As you can see, sorry for the bad quality of this thing because I just copied down the picture. So from the equation of OR, y equals to 1/2x plus r/2, and you just expressed the equation of x in terms of y, and then you will get x equals to 2y minus r, which is the first equation, and then you just plug the equation of 1 into the second equation, which is this one, and then you will get something like this. Well, you will get 2y minus r. Okay, instead of x, you plug in, you get a y, 2y minus r, and then minus 3r, and you just close them with a square, and then this one, the rest are not, they do not change. And then you will have a final equation, okay, in terms of y and r. And you can solve y in terms of r by using the quadratic formula. Well, just treat r as a constant, because, well, in this diagram, we can, well, why we can treat the r as constant, because circle A and circle B, they have the same radius, and circle A and circle B are inscribed in the rectangle ABCD. When they are inscribed in the rectangle ABCD, then well, they have basically no change in radius, and they just have the same constant radius according to our assumption, and hence we'll get two answers. Well, in this case, in quadratic formula, we're supposed to have plus minus in front of the square root sign, but because I just realized that if you plus them, you will have a 9r over 5 plus r over 5, and then you will get 2r, okay, which is the first solution of y, okay. And then 2r, you might notice that this is the 2r I'm referring to, which is the coordinate of r, okay. Okay, the y coordinate of r, which is the 2r. So we do not use the 2r, but instead we're looking for the coordinate of q. And that's the reason why we set the equations of 1 and 2. And hence we can get the coordinates of q. And then the coordinates of q, the y coordinate of q will be 8r5 if you use the minus. And you use back the coordinate of q, okay, the y coordinate of q, and then you plug in back into the first equation. So this is from the equation 1, okay. So I would like to recall back. I have an equation of OR, and I have an equation of the circle B, which is this B. The circle B intersects with OR with 2 points, which are the Q, this Q, and the R, okay? And R has a coordinate of 3r, 2r. So that's why when I solve for the YQ, the coordinate Y, the Y coordinate of Q, I have two answers. One of them is 2r, which I will eliminate because 2r is just the y coordinate of r, and then the rest, which is the negative one, will be 8r over 5, which is smaller than 2r, and this is definitely the y coordinate of q. And then just substitute back in the first equation, the green one, and then you will get the xq, the x coordinate of q. So we have already the O, we have already the P, which is r comma r, we have Q and also R, and hence yeah, don't be afraid. We have R, yes, not numbers but terms with R, with a small r. So we are able to get rid of it by using the ratio, the section formula. So we find the ratio of A to B, which is OP to PQ, okay? Now, we know the formula. Just recall back the formula. When we have the divider O between A and B, we're able to find the coordinate of O, okay? If we have the coordinates of A and B, okay? And also the ratio M and N. But in this case, we're gonna find the ratio, and we are given points, we are given these 3 points. So in this case, I'm finding the ratio of this one, A, and also B here. And later I will find the B and also C. They might have different numbers, but we just try to manipulate them for the best. And we try to just first and foremost find the ratio of A to B. And then we know that the coordinate of P is R comma R. And then O has a coordinate of 0, comma R over 2. And then Q has a coordinate of 11R over 5. And then comma 8R over 5. And then hence, with these 3 points given, we're able to find the ratio A and also B. Just try to compare this is the x coordinate, and then this is the x, and then also this one is y, and then on this r, okay, on the right side, which is the y, which is the r, and it's also the y coordinate of P. So x here equals to this entire thing. My apologies because I included the at sign. So I mean, you just ignore it, okay? Just ignore it, and you will get this equation, which is this one, when you compare the x coordinate, and then the second one, when you compare the y coordinates, and both of them, I mean, both will get the same ratio of A to B, which is 5, 6. So left one ratio of B to C, and this time we try to use 3 points, which are P, Q, and R. So R has the coordinate of 3R, 2R. Yes, we have 3R, comma 2R. So we use a P, Q, and R to find the ratio of BC. Using the same method, we will have BC is 6 to 4 or 3 to 2. But in this case, because we have a ratio of A to B, which is equal to 5 to 6, we must times the 3 with 2 to get the 6 for the B. And hence, by combining these both ratios, I will write to recall back AB equals to 5, 6, and then BC equals to 6, 4. We can combine them because B are already equal, and we will have A, B, C equals to 5, 6, 4, and that's all.